When you walk into a pharmacy or a hospital, there are dozens of different antimicrobial drugs on the shelf, and they are absolutely not interchangeable. Pick the wrong one and you might not treat the infection at all, or worse, cause seriously harm them. That's why every antimicrobial agent is classified by how it works, what it kills, and when you should use it. In this video, we'll walk through the key families from the beta-lactams that attack the cell wall to the protein synthesis inhibitors, the DNA disruptors, and the specialized antifungals and antivirals, so you understand not just what each class does, but why it matters at the bedside. So, here's the big picture. Every antimicrobial class targets something fundamental the microbe needs to survive. Its cell wall, its ribosome, its DNA, or the metabolic pathway it can't live without. The art of choosing the right drug comes down to 3 questions. First, what is likely the organism? Gram-positive, gram-negative, atypical, fungus, or virus. Second, what are the local resistant patterns? Is it MRSA a concern? Are ESBL producers circulating? And third, what are the patient's born risk factors? Renal function, allergies, pregnancy, drug interactions. That's why this chart is so valuable. It organizes all the key information like class, mechanism, spectrum, indications, and adverse effects in one place. Use it as your roadmap, and you'll never walk into an antimicrobial decision blind. Beyond the beta-lactams, there are other cell wall agents that work differently. Glycopeptides like Vancomycin also block cell wall synthesis, but they bind to D-alanine terminus of the peptidoglycan chain instead of PBPS. This gives them activity against gram-positive bacteria only including MRSA, which beta-lactams can't touch. Vancomycin is the classic drug for serious MRSA infections, but it comes with risks, nephrotoxicity, ototoxicity, and that infamous red man syndrome from rapid infusion. Then there is daptomycin, a lipopeptide that works by a completely different mechanism. It inserts into the bacterial cell membrane and forms pores, causing rapid cell death. It's also active against MRSA and VRE, but here's the catch. It's inactivated by a long surfactant, so you cannot use it for pneumonia. That's a classic board example. Bacteria aren't the only microbes we fight. Fungi requires completely different drugs. The 3 main antifungal classes target the fungal cell membranes or cell wall. Pollens like amphotericin B bind directly to ergosterol in the fungal membrane and punch hole in it. It's incredibly broad, covering yeast and mold, but it's also famously toxic, causing nephrotoxicity and severe infusion reactions. Azoles like fluoroquinolones and voriconazole are much safer. They block ergosterol synthesis instead of binding it directly. Fluoroquinolones is great for candida infections, while voriconazole is the drug of choice for invasive aspergillosis. The key insight, because fungal cells are eukaryotic like our own, finding drugs that kill the fungus without harming the patient is a constant challenge. Let's start with the biggest and most widely used family, the beta-lactams. These drugs, Penicillins, Cephalosporins, Carbapenems, and Monobactams, all share the same core mechanism. They bind to proteins called PBPS on the bacterial cell wall and prevent the cross-linking of peptidoglycan. Without that cross-linking, the cell wall falls apart and the bacterium bursts. Penicillins like aminoglycosides cover gram-positive cocci and some gram-negatives, but they don't touch MRSA. Cephalosporins are organized into generations, like first generation covers gram-positives well, later generations expand into gram-negatives, and fourth generations like Cephalosporins even covers Pseudomonas. Carbapenems like Meropenem are the heavy hitters. They cover gram-positive, gram-negatives, and anaerobes, and they resist most beta-lactams. That makes them the go for severe infections and ESBL-producing bacteria. The key takeaway: all beta-lactams attack the cell wall, but their spectrum depends on how well they reach and bind their targets. Well, this much for today. Thank you.